Hello, and welcome to the tutorial video for Acadec Math Focus Quiz 1, Simple and Compound Interest. The majority of takeaway that you need to get from these concepts are the actual equations themselves more than any tips or tricks. So, this is the equation for simple interest, and I'm going to explain what each of the variables are. These are essentially the same equation, and I'll show you the difference, and I'll tell you when each one is more useful than the other. So, P stands for principal. So if you think about putting money into, I think that's I'll cross-check how that's spelled later. If you think about putting money into a savings account that will grow over time, or taking out an amount of money, the original amount that you put in or take as a loan is the principal. R is the interest rate, which is almost always going to be per annum, or the annual interest rate. So this is rate. And that'll be something like 4%. And in this equation, if it were 4%, then in the equation, you would actually write 0.04. If you accidentally put a 4, you're going to have a really big problem and not get the question right. T is time, and this is also pretty much always measured in years for simple interest, and the other one, we'll talk about it, but this is time in years, pretty much always. A is your final value. So if principal is how much you put in, A is after a number of T years at an interest rate of R, A is how much you actually are going to have. So final value. I, which I should probably always write as that so you don't get it confused with 1. This is an even simpler version of the equation. So if you use this equation, instead of giving you the final value, so say you put $50 in, your final value might be something like 75. I, in this shorter equation, gives you just how much interest you make. So for that same $50 problem that's worth 75, if you put the same numbers into this equation, you would get 25 as I. So we'll call that value of interest. And depending on how the problem is written, you'll want to choose one or the other. You can usually you can get the actual interest and the final amount from either of these equations. They're just quicker for different types of problems. So very important that you write these equations down and memorize them. You need to know these. You don't always need to memorize equations for certain bits of math, but these you need to know, and you'll see why. This is the compound interest equation. And all of the other variables are the same, but there's a new one, n. N is the number of times that you compound the interest per t. So a very common one is that something is compounded monthly. So, well, let's write this first. Times compounded per t. Forgive my handwriting, the tablet's difficult to use. So a very common one would be monthly, and it won't tell you 12. So monthly would be 12 in this equation. So for n, we're going to put 12 in both slots if the problem says it's compounded monthly. Another one could be semi-annually, and that would be 2. One could be bi-monthly. That would actually be 24 if it's over a period of a year. So you got to keep all those in mind and get used to them. Besides that, you can see that this is a very similar equation. T is in an exponential spot instead of inside of here, but you do need to have both of these memorized. If 3 of them is too much, ignore the one with I. Just do this one and this one. Here's a problem, and this is just the most basic simple interest problem that you could possibly have. We're just going to be filling in our equation. So, at the end of 5 years, using simple interest, how much will an initial investment of $2,500 at an interest rate of 12% be worth? It wants to know the total worth of the investment at the end, so we're going to use our first equation, and I'll just write it down. A very good practice, if you have difficulty remembering these equations, is going into the test, writing them both at the top of the page for reference. Just having them memorized right before the test, and then writing them down at the top, and that's kind of like a little formula sheet. That can help you out a lot. So, A equals P. Sorry, I'm thinking about the fact that I say so every time I'm ready to segue. P1 plus RT, and then we're going to fill in what we know we have. Our principal is 2,500. Our interest rate, that's just a 1. Our interest rate is 0.12. Make sure you don't put 12 times 5, our T. And then we'll go plug that in. And so 2,500 times 1 plus 0. I have this somewhere up there. 0.12 times 5, 4,000. So the answer to this question would be $4,000. Cool. That's the simplest type of problem you can get. This one is more of an algebra problem, and this is why you need to have the equations memorized. The simple interest, so that's our equation is going to be simple interest, on a sum of money for 5 years at 3% per annum is $82.50. Find the sum of money. So we're looking for the principal. The equation with I is quicker to use here, though you could use the other one. This makes it a lot easier to do. I equals PRT. And we're going to fill in what we know. We know I, which is the interest made off of this investment, is 82.5 equals P, which we don't know, times our rate is 0.03 times 5. And then I'm going to show you a trick called NSolve. Really, you can do the algebra for this. If you're truly time crunched, NSolve is pretty nice. You're not going to want to type out NSolve. You go to menu 3 for algebra and 1. So menu 3.1 will get you NSolve. And then the way you use it is you type out your whole equation. So for us, that was 82.5 equals, and I'm going to use X because you know where it is. It's at the bottom, X, Y, and Z. That's our P in this case, times 0.03 times 5. Yes. And then at the end of an NSolve thing, you have to tell it what you're solving for. So you do comma, and then whatever variable you used in the equation. And then we'll have it go. And the answer, solving for P, is $550. Cool. NSolve is a very useful tool. You do need to be careful. There are cases wherein it will, like especially with anything quadratic, systems of equations, it's not going to always give you the answer that they want because it'll find a different one that is perhaps like negative or... Anyways, don't use NSolve for everything, but for really simple linear equations, it is very useful. Because if you have trouble with doing algebra quickly, it does it for you. Bilbo bought a house. He borrowed 25,000 Shire farthings at an interest rate of 6% APR, compounded monthly. So that APR means that the 6% applies to a year. I'm sure you've seen a car commercial and they talk about this. Assuming he makes no payments, how much does Bilbo owe after 9 years? So this is simply filling in the parts of our compound interest equation of final value equals principal times 1 plus r over n, so our interest rate over, in this case, 12, because it's compounded monthly, raised to the n times t. So we're going to fill in what we know. We're looking for A, how much does Bilbo owe, equals 25,000 times 1 plus, and we have 0.06 over 12 raised to the 12 times 9 years. And then we're just going to plug that in. Now, I want to tell you there is technically a finance solver in the calculator, but for this level of it, you are going to waste time in it. You will get, more often than not, you will get the wrong answer because you have to fill in other parameters besides what we're filling in here. Don't touch it. Just don't do it. There might be something later on that you do need to learn that for. Not this year. Don't touch it. So we're going to fill in 25,000 times 1 plus, and then I always, you hit control divide to actually make this thing. I always do this, just it forces order of operations so you can't accidentally mess up your problem. 12, and then we're going to raise it, wrong button, to 12 times 9. And after 9 years, Bilbo owes 42,000. I can't write that. That's just a random alt code. 42,842 Shire farthings and 50 hundredth farthings. I don't know. So that's your answer. And again, writing the formula at the top of your sheet makes this a lot easier. If you have it memorized, good for you. If you have a lot of difficulty with that, memorize it right before and write it right when the test begins. An investment pays a total interest equal to the original investment over a period of 15 years. So this requires you to know the equation and also be able to play around with it. So let's think about what this means. An investment pays a total interest equal to the original investment over 15 years. Calculate the simple interest so we know which equation we're using, interest rate of this investment. We can write this two ways. If you only have the first one memorized, if it pays interest equal to the original investment, right, that means that it has doubled in value. So we can, with our equation, we know that A is going to equal 2P. Our final value is going to be twice what we put in originally. And then we can use that to get only one variable in this equation, and it'll be significantly, well, that you have to do that in order to finish that. This is what you have to be able to do to complete the problem. And then we can fill in what we know and solve. I think it is easier to use the other equation for this. It's objectively is. If we know that the investment pays interest equal to the original, then with this equation, we know that the interest made equals P. So we can interchange these two. I will write P for both of them. P equals PRT. And then we can solve from there. We don't know P. Or no, yeah, we do. We're going to divide out P from both sides, and we're going to get 1 on this side. Not I, 1 equals RT. And we know our period is 15 years. So 1 equals R times 15, which means that R equals 1 over 15. Or that is 0.06 repeating, which we can write as 6.7%. You need to know the equations in order to solve this problem. You can't just throw it into a finance solver and get it done. You potentially can. It's unlikely to be a reasonably quick method. The value of a chicken sandwich depreciates by 15% every year. Depreciation is really similar to compound interest. In this case, we don't have a period, so it's going to look a lot like simple interest. If the original value was $17, how much is it worth 3 years later? So the only difference for this is that instead of 1 plus, we're going to do 1 minus. So we're going to fill in some stuff here. A equals P times 1 minus 0.15 raised to, technically there's an N under here, but it's just 1 because we only compound once per year. And 1 times 3 years later. We can simplify this inside part and plug in our numbers. We have 17 times 0.85 raised to the third. And that is going to equal $10.44. So depreciation is kind of similar. You just need to keep in mind that you are subtracting instead of adding. This is me reminding you that you need to know the equations. You really have to get comfortable with them. This is the last problem. I can't show you every single way in which they are going to throw you for a loop with the equations. They're going to set stuff equal to each other. They can do whatever they want, and you just need to be comfortable doing the algebra. After how many years would an investment grow to 4 times itself at a simple interest rate, so we're doing simple interest still, of 25% APR? A equals P times 1 plus RT. We're going to fill in what we know and then equate what we know to other parts of the problem. If an investment grows to 4 times itself, then that A is going to equal 4P. And we could also write this with the I equation, but I think it's a little more intuitive to use this one in this particular case. So 4P equals P times 1 plus, and we're looking for how many years, so we don't have T, but our interest rate is 0.25 T. And this is, it's going to be a lot easier to use numSolve. We can divide P from both sides, and then we have 4 equals 1 plus 0.25 T. And we're going to go put that into nSolve. You don't have to, but if you didn't recognize that dividing out P part, then this would be a lot quicker. nSolve, which remember is menu 3.1. nSolve, we're going to write out our whole equation, and I'll write it out with the variable just so you can see that you can put your stuff wherever. As long as it's a linear equation, it will know what to do. So that x is our P. 1 plus 0.25. Wait, that x is not our P. Ignore it. We did divide it out. 0.25x, comma, x. And our answer is 12. 12 years. At a simple interest rate of 25% APR, any amount of money, P, will grow to 4 times its original amount after 12 years. And that's our last problem. The thing you really need to understand is that you need to know these equations. Write them at the top of your sheet, reference them for an actual competition. There's going to be multiple things you have to have memorized. Find the ones that you have difficulty remembering on the spot. Maybe you flip where the N is or whatever, and you know you have that problem. And memorize them before the test and write them at the top. The math test is pretty much always the first one, if I remember correctly, so you'll have time to study beforehand and prep whatever internal formula sheet you want to copy down that you need to.